we would understand what are acid, what are base and what are salts, how do we differentiate those, and how do we use various indicators to understand the difference between acid, base and salts. What are acids? The word acid comes from a Latin word which is acer, that means sour. For example, I take lemon juice. So this is the lemon juice I have in the beaker, and this lemon juice is acidic. Now, what is the acid here? We say this is the citric acid. Similarly, you have lactic acid in milk. Even in animals, there is formic acid. You might have witnessed an ant bite or an insect bite sometime, and then you have certain kind of swelling on the skin. Why does that happen? That is because of the acid released by the insect on your hand, and this is the formic acid. Now, in order to neutralize any acid which occurs, what is the right strategy? The right strategy is to use a base. Once acid and base combine, what would happen? A salt would be formed along with water, and this is what is the process of neutralization. So whenever there is an acid, if this acid reacts with a base, you get salt and water. Commonly, in layman's term, you might have heard if there is an insect bite, apply some toothpaste, probably that would relieve the swelling and the pain. And that is why we say acid is being neutralized by the base here. So common examples of acid is citrus fruits, vinegars, anything which is sour would be a good example to say that this is acid. Now, acids are corrosive. There can be serious burns by acid if not properly handled. Even in laboratories, we use dilute acid. So, if you are using HCl in laboratory, you might have heard 3% HCl solution. That means it is diluted to only 3%. Also, if you visit a chemistry lab, you would see most of the acids in the shelf are stored in glass bottles. Why is it so? Because acids are corrosive. Since they are corrosive, they have a tendency to corrode, and therefore they cannot be stored in plastic containers. The only non-reactive good container we can say here would be glass, and therefore acids are stored in glass bottles. Now, acid reacts with certain metals and carbonates in different fashion. So we'll understand each of the examples. The first example is when an acid reacts with metal. Now when an acid reacts with metal, I take an example of zinc, you can take an example of aluminum or any other metal. What would happen? The metal chloride would be formed. So when zinc reacts with hydrogen chloride, zinc chloride and hydrogen gas is released. And this is where metal reacts with acid. There is formation of metal chloride. Clear? The next important reaction that we understand is metal reacts with carbonates. Now, what is the carbonate we are using here? Calcium carbonate, CaCO3. So, acid reacts with carbonate, and when acid reacts with carbonate, what is formed? Salts are formed. So, CaCl2 and water and carbon dioxide are released. The next is acid when reacts with base, as I already said. So what would be the formation? The formation is salts, and this is in the case of sodium hydroxide reacting with hydrogen chloride, HCl, you have formation of common salt, NaCl. Let's talk about another good example. You might have seen sometimes utensils have kind of deposits within the surface, and even the gas burners have deposits towards the side. And what is used? Acids are used for the purpose of descaling. We call this as a process of descaling. So whatever salts are deposited, those salts are removed with the help of acid, and this process is known as descaling. Usually acid along with hot water is used to descale. Even we say that acids can be classified into three various categories. One is the organic acid and the inorganic acid. The next is strong and weak and concentrated and diluted. So organic acids are those acids which are found naturally. They can be from plant, they can be from animal. I talked to you about let's say formic acid from animals, insect bite and bite. Plant, we have tartaric acid. This is from tamarind. Similarly, acids can be strong and weak. Strong acids, HCl, hydrogen chloride, nitric acid, sulfuric acid, all of these are strong acids, even responsible for phenomena like acid rain. On the other hand, if the same acids, we can say the same acids, the hydrogen chloride, nitric acid and sulfuric acid can be in the concentrated form. Concentrated means very less amount of water is present. However, when I say dilute, you have more amount of dilution or water in which it is dissolved. So 3% HCl when I say is a diluted HCl. So these acids, strong acids, are usually diluted in order to avoid any kind of burn or corrosion that can occur. Then we do have weak acids. Acids which are not that strong. For example, we do consume lemon and definitely lemon acid is not that strong. So we call this as a weak acid. So citric acid is a relatively weak acid. Our stomach acid, which helps in the digestion, is a strong acid. Similarly, there is acetic acid. Acetic acid is again a weak acid. Oxalic acid, again a weak acid. So usually we can say organic acids which are found from plants which are consumed by human beings are usually not that strong. So we have certain list of acids here. Milk and milk products, definitely we know lactic acid. We also talked about lactose intolerance in other lectures. Tomatoes, we have oxalic acid. Tamarind, as I already mentioned, is tartaric acid. Citrus fruits have citric acid, so citrus and citric, so lemons, oranges, all those which have vitamin C. Now also those which are rich in vitamin C, for example amla, guava, have ascorbic acid. Even if you are consuming vitamin C supplemental tablets, that is ascorbic acid. So ascorbic acid usually related with vitamin C intake. Then vinegar has acetic acid. Apple has malic acid, and then as I mentioned, insect bites, insect stings have formic acid. So those are some of the common acids. The top ones that we mentioned are the plant acids, and the bottom one that we mentioned, the formic acid, classically is a animal acid. Both animal and plant acids which occur naturally are known as organic acids. So these are examples of organic acids, but we do have acids which are inorganic. Now inorganic acids are those which are not available naturally. So HCl, which is hydrogen chloride, then you have nitric acid, sulfuric acid are examples of inorganic acids as well. So this is understanding the acids. Now acids can be tested through various ways. Let's say I have a universal indicator here. Now this is a universal indicator strip which occurs. Now this universal indicator strip is a very unique strip. It behaves similar to a pH scale. That means in an acid solution it would turn what? It would turn red and towards red, so orangish, reddish, and in a strong basic solution it would turn bluish. So this I am trying to test the acid here. I have lemon juice and this universal indicator. I dip this universal indicator, and as you can see, a good red color can be seen, indicating that this lemon juice is what? This lemon juice is acidic in nature. Now we would understand base in a while, but just to have an example, I have choline, which is the glass cleaner, and with this choline I just put a spray here And as you can see, this universal indicator turns blue. This universal indicator turns blue, indicating that this is basic in nature. So that this is how we understand acids. What are base? Now, to identify base, there are two important characteristics we can understand. Firstly, bases are bitter, and if you touch the base, it gives you a soapy feeling. You would need to wash your hand. I have choline, which is a base here. I spray it on my hand, and definitely it gives me not a good feeling. So it is soapy in nature. Now, what are other examples? Toothpaste, shampoo, baking soda are other examples where we say base is they are basic in nature. Strong bases and weak bases, similar to acids, strong acids and weak acids, we also have bases which are strong and weak. Now, strong base note are similarly corrosive as the acids. However, weak base are not that corrosive. Examples of strong base is sodium hydroxide, potassium hydroxide. They are strong base. I have sodium hydroxide as an example here, and this is a strong base. So bases which are strong actually give a very significant color on the indicator. Let's understand with the help of an indicator. So this is a universal indicator. It has marking from 1 to 11, showing that those close to or less than 7 are acidic in nature, similar to a pH scale, and more than 7 are basic in nature. The ones which are basic would give you a bluish purple color. However, those which are acidic would give you orangish red color. Now, what I do is, I simply take one of the strips of this universal indicator and take choline as an example again, which is basic in nature, and spray it. As you can see, the color changes immediately to blue, indicating that this is a base. Now, also when I talk about base, we need to understand that these bases are explained either as strong base or weak base. So strong base, we already gave you the example, sodium hydroxide, potassium hydroxide. Weak base, what would be the example? Weak one. So magnesium hydroxide. Then you have ammonium hydroxide. Ammonium hydroxide is also used in fertilizers. Then we also have copper hydroxide. So these are all examples of weak base. Coming on next is base can dissolve in water. They cannot dissolve in water. Those base which dissolve in water are called as alkalis. What can be alkalis? Sodium hydroxide. Then we have potassium hydroxide. All these are alkalis because they have a tendency to dissolve in water. Now, base can react with acid. In the first example, we have ammonium hydroxide reacting with hydrogen chloride to form ammonium chloride, which is a salt. So there is a base which is usually the OH group. Then we have the acid, H plus ions. So acid and base react to form salt and water. The first one. The second is metal, which is zinc. It can be aluminum or any other metal, reacts with base. Now when metal reacts with base, there is formation of the salt. Now what salt is formed here? The salt which is formed here is sodium zincate. So when sodium reacts with sodium hydroxide reacts with zinc, sodium zincate is formed along with hydrogen gas which is released. So this is some of the important characteristics of bases. Now, what are the common bases and where they are found? Calcium hydroxide. Calcium hydroxide we know well, lime water. Now I have been talking about example of choline so far. So choline, which is the window cleaner, usually have a weak base which is ammonium hydroxide. Then we have sodium hydroxide, potassium hydroxide. Sodium hydroxide and potassium hydroxide are commonly seen in soaps and detergents. Then when there is a lot of acidity, As I said, milk of magnesia is used. What is milk of magnesia? Nothing but magnesium hydroxide. So magnesium hydroxide is again a base which is used to neutralize the stomach acid and form salts. So magnesium hydroxide is used as for indigestion, commonly called as milk of magnesia. Milk of magnesia is the commonly prescribed thing which is given for indigestion. So those are some of the examples of base. And how do we actually identify base? Similar to acids, base can be strong and weak in nature. The strong bases are more corrosive. Base can dissolve in water. Those bases which dissolve in water are known as alkalis. Now, be it acid or base, they can be identified with indicators which we would understand in the next section. And also, acid and base react to form salts, and this process which we have understood in our first equation explains the process of neutralization. How do I identify whether a solution is either acidic in nature or basic in nature? The very simple way is with the use of indicator. There should be some indicator. Even if on the road, if you are driving and you want to take a turn, you would point an indicator whether you want to take a right turn or a left turn. So indicators help us understand an indication what the thing actually pertains to. Similarly, with the indicators here, we can understand whether the solution is actually acidic in nature or basic in nature. Now, there can be numerous indicators. It's not required that you have to be in a chemistry lab to understand whether the solution is acidic or basic in nature. You can try it at your very home itself. Now, we would understand indicators in two ways. Indicators can either be natural or they can be synthetic in nature. Today, we would understand examples of 4 natural indicators and 3 synthetic indicators. So, let's begin with the natural indicators. The first natural indicator that we talk about is litmus. You might wonder, this litmus is obtained from what? This litmus is natural. It is obtained from lichens. And originally it is purple in color in distilled water. If it is extracted from lichens, it is purple color in distilled water. And then for the laboratories, we do have the 2 litmus paper which are commonly used. Those are the red litmus and the blue litmus. I have an example of a red litmus here and a blue litmus here. Blue litmus turns red with acidic solution. How do we understand this? So I just take one strip of this blue litmus paper. As you can see, it is pure, it's blue in color. Okay, there are 2. So I'll just take one. Now I have some lemon juice with me. In this lemon juice, I dip this litmus paper, and as you can see, the color changed to pinkish red. And this is how we understand blue litmus turns red in a acidic solution. So this was a blue litmus turning red. Now when I say blue litmus gets red, so you can remember this as bar, a good chocolate bar. So enjoy that. B for basic, B for blue, okay, A for acidic and R for red. So how do you remember? Blue litmus turns to red in a acidic solution, and we remember this as BAR bar. Now I take another example. I have the red litmus paper. The red litmus paper, if you open, is actually pinkish white in color, not actually red. But this is the litmus paper. We call this as red litmus. Now on this red litmus, I have a window cleaner, and as you can see, this red litmus turns blue. Now whatever we are studying, we would understand those with the color combinations and the color code here. Now as for the litmus paper, in acidic solution it turns red. We have written this in a red box to help you understand. And blue in basic. Okay, so in basic solution it turns blue. Now this is very, very important. If the solution is neither acidic nor basic, I don't have an example of water here, but if you drop it in the water, what would happen? There would be no change in the color. And we call these solutions as neutral solutions, the substances which are neither acidic nor basic and their pH is 7. So pH is an indicator. If the pH is less than 7, we say it is acidic solution. If the pH is more than 7, we say it is basic solution. So the first natural indicator we understood is litmus. The second natural indicator is China rose, hibiscus flower. Now hibiscus flower is interesting. You take that hibiscus flower, crush it and keep it in water for some time until that hibiscus water actually leaves its color and the water becomes pinkish. Now that pink water, if you keep it in if you react it with a base, it would give you green color. However, if there is acid, it would become magenta, dark pink in color. So China rose, again a very good example. You can get some hibiscus flowers from your nearby and try this at your home. Good examples you can take is the common household examples we are taking. So lemon water is a good acidic example. Window cleaner could be a good basic example which you can take, or antacid tablets if you have is another good example that you can take. The next is for a base. Okay, so China rose you can definitely experiment with. The next natural indicator which we talk about is turmeric, commonly called as haldi. Now I have this cloth which I actually dipped in the turmeric water, and this cloth is yellow in color. Now what would happen if I dip a piece of this cloth in this lemon juice? In this lemon juice, if I dip it, the color does not change. It remains yellow only, and therefore turmeric in acidic solution remains the same color. It is yellow. But this turmeric cloth which is dipped in turmeric water, I have certain base which is the window cleaner that I spray, and as you can see the color changes to brick red, and turmeric therefore is a natural indicator indicating that this window cleaner is an example of a basic solution. In a basic solution it turns brick red in color. So this was about turmeric. The next indicator that we understand is cabbage. You might have enjoyed red cabbage as a vegetable. This red cabbage is again a very good indicator. The juice from the red cabbage is purple in color. If this is dipped in acidic solution, it gives red color. If it is dipped in a basic solution, it gives green color. So red cabbage, another good natural indicator. 4 natural indicators that we have discussed. What are those? Litmus, obtained from lichens. Then we have turmeric. Then we have China rose and red cabbage. Now we would move to synthetic indicators. The first synthetic indicator we would talk about is phenolphthalein. I have the phenolphthalein sample here. So this is how phenolphthalein powder actually looks like. Now this phenolphthalein I have dissolved in water. Now this is a phenolphthalein solution. If I take this phenolphthalein and I put some acid in it, what would happen? This phenolphthalein would remain colorless. But what would happen with the base? With the base, it would change to pink. Now, I just have this much of phenolphthalein. I don't have the water here, but no worries. I keep this in 2 flasks. So in one flask in these 2 flasks, we have the phenolphthalein solution. Okay, now in the bigger flask, let me put some lemon drops. I put some lemon drops here, and let's see, is there any change in the color? No change. So with acid, this phenolphthalein gives no change in the color. Now with this phenolphthalein which is left, I put certain base in it. So I put in certain amount of window cleaner, which is again a base, ammonium hydroxide, and as you can see the color changes to pink. So phenolphthalein gives pink color in a basic solution. However, it remains colorless with the acidic solution. So you can clearly compare phenolphthalein. Now, let's proceed further with the next synthetic indicator. The next synthetic indicator, which I don't have it here, is methyl orange. Methyl orange is orange in color, as the name suggests, but in acidic solution it turns red, in basic solution it turns yellow. Very, very important. Okay, the next indicator is the universal indicator. So we have this universal indicator strip here. Now again, I take one of the strips of this universal indicator. This universal indicator is greenish yellow in color. Now this universal indicator would behave similar to a pH scale. So in the pH scale, the acids would be indicated with red and the bases would be indicated with shades of blue. So I take this universal indicator, I dip it in lemon juice, and as you can see, it turns orangish red, indicating that the lemon juice is acidic, citric acid is present. Now the next is the same. I'll conserve the paper for now. Okay, so with the same universal indicator, I spray the window cleaner again, which is a basic solution, and as you can see, it turns blue. So the chart, you have it here, you can compare it with our findings and see how it actually happens. So universal indicators behave very, very similar to the pH scale. Now the pH scale, we have mentioned it again here. So tomatoes which are having oxalic acid are weakly acidic. However, our stomach acid is highly acidic on a pH of 1. Similarly, water, as we know, is neutral, but stomach medicines, antacids, as we said, which or milk of magnesia, magnesium hydroxide, is weakly alkaline. However, bleach is a strong alkaline in nature. So with this pH gradient, we have the bases which are indicated by shades of the acids which are indicated by shades of red, the bases which are indicated with shades of blue. So summarizing the various indicators again, 4 natural and 3 synthetic. So the litmus is a natural indicator from lichens. The blue litmus turns to red in a acidic solution. We remember this as a bar, chocolate bar that we eat. So blue litmus, B for blue, R for red, changing in a acidic solution, and that's how we remember it. And vice versa, red litmus changes to blue in a basic solution. China rose, hibiscus, the common flower, turns green, the solution turns green in a basic solution, pink in a acidic solution. Turmeric remains same in acidic solution, but in a base it turns brick red, as we have seen in our demonstrations. Then red cabbage remains red in acidic one, but turns green in basic. So remember, both China rose and cabbage behave similarly. They turn green in a basic solution. Very, very important. Then synthetic indicators. Phenolphthalein, a good synthetic indicator, turns pink in a basic solution, as we have understood. Then we have universal indicators. Universal indicator in an acidic solution would become red and in a basic solution would turn blue, and then methyl orange turning red in acidic solution and yellow in basic solution. So this was a quick recap of the various indicators. What is neutralization? Neutralization is a simple process of reaction of acid and a base to form water and salt. Now, this is the process where heat is released, and in this process we have, let's take a very simple example of acid, hydrogen chloride reacts with sodium hydroxide to form the common salt, which is NaCl, and water. Now, when we have various indicators, we have seen changing colors with the indicators in order to understand how acids and base react. But this process of neutralization is actually very, very important. I have some common life examples where this process of neutralization is used. Sometimes you do enjoy the food outside, but when you return back, you feel indigestion. Now this indigestion is because our stomach is acidic. Now when this amount of acid in the stomach increases, you need to have certain base in order to neutralize it. For indigestion, what are the base used? We commonly say antacid is used or milk of magnesia is used. Now all of these are examples where base would react with the stomach acid in order to neutralize the effect. And what is the base here? Magnesium hydroxide is the base. Now I take another example. My another example is ant bite. Ant or insects sometimes bite us when we are playing in the garden or outside. What is the acid which is released by the insects? We say it is formic acid commonly. Now this formic acid actually needs to be reacted with a base in order to neutralize. So what can be good examples? You are commonly asked by your great grandparents or great grandparents to use toothpaste as a remedy commonly. So toothpaste is used as a remedy. Other common remedies are moist baking soda. Anything which is basic and commonly found at household is something which is used in order to get rid of this issue. So baking soda, moist baking soda, toothpaste are good examples. Sometimes if you are having solution at home, calamine solution is another good example. Calamine solution is nothing but zinc carbonate. So zinc carbonate is also used as a base in order to neutralize the acid. So two common examples of indigestion of insect bite we talked about. The next common example is soil. The soil structure sometimes can be too acidic. So what is used is potassium hydroxide. We call this commonly as potash. So potash is used in order to neutralize the soil if the soil is too acidic. If the soil is too basic, what is used is the acidic mediums which can actually neutralize it. So soil and the fertility of the soil is based on how well the soil is. It's neither too acidic in nature nor too basic in nature. And acidic soils are usually neutralized. How? They are neutralized by lime water. We also say this as slaked lime. The next is wastewater. Wastewater effluents from industries actually run into the water streams and they are highly acidic in nature. What is done to neutralize that acid? Calcium hydroxide or lime water, again slaked lime, is commonly used in order to neutralize the industrial effluents which are seen in the water. Now, this is how we understand neutralization. So anything which is either acidic or basic having a pH of less than 7 is acidic, more than 7 is basic. We try to neutralize it at 7 and we call these as neutral substances. So soap is a good example of being a neutral substance. Water definitely is an excellent example of neutral, which has a pH of 7, a neutral pH. Now, whenever salts are formed, there can be three kinds of reaction. A strong acid reacts with a weak base. So first example that I take is a strong acid. Let me take as HCl reacting with a weak base. When the strong acid reacts with a weak base, what would be formed is a acidic salt. So this salt would be acidic in nature because acid is more prominent. Acid is strong there. Good example is weak base, ammonium hydroxide. So weak acid would be ammonium chloride, which would be formed. The next example is when you have a weak acid. This weak acid reacts with strong base. When the base is strong, we call this as a basic salt. What would be a good example? A good example of basic salt would be sodium acetate. So sodium acetate formed by weak acid, which is the acetic acid. Acetic acid is a weak acid which we can take into account, and then it reacts with a strong base. What is a strong base? NaOH or sodium hydroxide. So when it reacts with sodium hydroxide, there is a basic salt which is the sodium acetate which is formed. The next important case is when a strong acid reacts with strong base. Strong acid we know is HCl. Strong base is NaOH. sodium hydroxide, hydrogen chloride reacting with sodium hydroxide to form a neutral salt. So when both of them are strong, neutral salt would be formed. And what is a neutral salt? The common salt that we consume. So NaCl would be an example here in this reaction. So salts can be three types, as we said: acidic salts, basic salts, and the neutral salts. And how these are formed, the reactions we have understood. So a strong acid when reacts with weak base would give you acidic salt, weak acid and strong base would give you basic salt, and strong acid and strong base would give you a neutral salt. Now talking about some examples of common salts from our life. Now common examples of salt, you have ammonium chloride, NaCl, the common salt, used for flavoring, used for preservation. Sodium carbonate, Na2CO3, commonly used in detergents. Then we have sodium bicarbonate, baking soda, commonly used for bakery products, also used in antacids, fire extinguishers. Then we have potassium nitrite, KNO3, which is used in gunpowders, fertilizers. Calcium carbonate, slaked lime, we use slaked lime to form the calcium carbonate, is the salt obtained from slaked lime. So marble formation of cement would be where calcium carbonate is used. And then we have copper sulfate. Copper sulfate is a salt which is commonly used as fungicides. So these are some of the common salts and their uses that we understand. So this was about understanding how with the acid-base reaction salts are formed and water as a byproduct of it. The salts can again be of three types. They can be acidic salts, basic salts, or neutral salts, and where all these salts are utilized.